Hello all, I am Professor Snehal Shinde from JSPM Nari Technical Campus. Today we are going to study the subject computer graphics. From this subject we are going to discuss some of the points from 5th unit, that is shading and hidden surfaces. The points that we are going to discuss in this session are the basic concepts of Warnock's algorithm and different cases of subdivision. Now this Warnock's algorithm, it is also called as area subdivision algorithm. We again, in the very first session, we have seen that for detecting visual surfaces, there are two approaches available, that is image space method and object space method. So this Warnock's algorithm or the area subdivision algorithm uses image space method. To reduce the calculations, it uses area coherence. Again, in visible surface detection, we have seen various coherence properties. Under that, we have seen this area coherence. We consider area of the projected image. As this algorithm uses this image space method, we know that in image space method, it deals with the projected images. So here, the area of the projected image is considered. Now, if it is easy to decide which polygons are visible in the area, we display it. Okay, so this you will understand in detail with some examples. But to see the concept of this algorithm, what we do, if in particular area the polygon is directly visible, then we will directly visualize or we will display that polygon on the screen. Otherwise, if it is not easily visible, what we will do, the area is subdivided into smaller areas and the decision is made recursively. Okay, so as the name suggests, that is area subdivision. If it is not easily visible, what is done here, the area is subdivided into smaller areas and then the decision is made recursively. Okay, and therefore it uses a divide and conquer strategy. As we are going to divide each time recursively, we are going to divide the area into subparts. It is said that this algorithm uses divide and conquer strategy. Now consider that the area is equally subdivided as per need. Now suppose in figure A, this is suppose the area of interest, that is this is the area that we want to or over which we have to display some of the objects. Okay, now here if the objects are directly visible or single object is there, we can directly display it. Okay, but some intersecting or overlapping objects are there, what we have to do, we have to divide this particular, as the name is area subdivision, this area is divided into equal parts, that is there are 4 parts now available. And suppose in this particular portion the object is clearly visible, we will display it. Here it is clearly visible, we will display it. If it is not, then this particular area will be subdivided further. That is recursively it goes on subdividing. So in the third case, in this particular portion, suppose object is not easily visible. So this particular portion is divided in some parts. Okay, so as per need, we are subdividing the area, and the tree's data structure can be drawn like this. Suppose this is a single area, we can simply represent it with a single node. Then this first node is subdivided into say 4 parts here. So this is how it is displayed with the 4 edges. Then it has initially 4 edges, then one of the area is again divided into 4 parts. So one of the area is again divided into 4 parts. So you can think this as a tree data structure. Now, we observe the relationships of the polygon with respect to the area to be displayed. And that is what we are deciding at 4 different cases. Okay, and these cases decide what to do. As I told you, as per need only, we are going to divide. Okay, now here we have defined, that is no subdivision is required in following 4 cases if the following 4 cases meet. Okay, so we are going to see some 4 cases where we don't need to divide the area. Okay, so the first case is a disjoint polygon. Now what do you mean by disjoint? Disjoint means what? no overlap between the polygon and the area of interest. As you can see this figure, this is the area of interest, that is your screen, and this is the polygon. These two elements are separate. Okay. Now here I will give you the simple example again, that when you are looking from the camera lens, you get one rectangle on the lens. Okay. Whatever area comes into that rectangular part, that only you capture. If one tree is available out of that rectangle, you will not capture that tree. Okay. So here also, this is our area of interest, or this is a rectangle part, and this polygon is disjoint. It is not intersecting or not at all contained into this area. So we can say that this is the disjoint polygon. So we have to ignore this polygon. Okay. So what we will do, if the polygons are disjoint, then the color, the area with the background color. So if we want to display only this much area here, only the background color will be filled in. Okay. So this is the case of disjoint polygon. Second is what? Surrounding polygon. As the name suggests, your area of interest is surrounded by a big polygon over it. Okay. So polygon is surrounding the area, and that's why it is called as the surrounding polygon. Now, if only one surrounding polygon, that is no contained and intersecting polygon, these two terms we are going to see in the next slides, okay, then that area is filled with the color of surrounding polygon. Okay, now what happens here, this is our area of interest, and this is the bigger polygon than the area of interest. Okay, so here you can think, we have already learned the concept as polygon clipping. Okay, whatever is visible into this area, that only clipped. Okay, so this polygon, total polygon, it will be clipped up to these edges. Okay, so definitely the whole area of this screen will be colored with a polygon color. So that is what I have said here. That is only one surrounding polygon, then area is filled with the color of the surrounding polygon. Okay. Now, next is contained polygon and intersecting polygon. Okay. Now, as the name suggests, contained polygon means what? You can see here, this is the area of interest, and this is the smaller polygons. A single polygon is available into this area. We can say that this triangle is contained into the area. It is inside that area. Okay. And the second case means what? Intersecting polygon. This particular polygon is intersecting the area of interest. That is, the triangle's partial part is visible. Here also we can think this as clipping polygon. Okay, so if I clip this polygon, only this much shaded part will be visible. Okay, so in that case, what happens here? If only one intersecting or only one contained polygon is inside the area, then the area is first filled by the background color, then the polygon part contained in the area. So this part will be first filled in by the background color, and this particular, suppose this is blue color. Okay, so I will fill this triangle with blue color. Again, same is here. This whole area will be filled in with the background color, and only this much shaded part will be colored by the, suppose it is pink color of rectangle of this triangle here. So I will fill pink color over this portion. Okay. Now, more than one polygon is intersecting, then contained in or surrounding the area, but with surrounding polygon in front. Then fill the area with the color of the surrounding polygon. Again, here also, this is also one of the case where we are considering no subdivision. Means what we have said here. Suppose now there are some intersecting polygons in the area of interest. There are some contained polygons, and one surrounding polygon is also available. Now, surrounding means what we have already seen here. This was the surrounding polygon, okay, where the whole area is surrounded by the polygon, right? So if suppose intersecting polygon is there, a contained polygon is there, and one surrounding polygon is there. But what is the case given here? Condition is given that, but the surrounding polygon is in front. Okay. So in that case, the area will be filled in with the color of the surrounding polygon. Do you agree? Okay. Now, in all these cases, you don't need to subdivide the area. Okay. So up till now, what we have seen, all the cases that we have seen, there is no subdivision required at all. But the name of this algorithm is what? Area subdivision algorithm. Okay. Now consider this diagram. Okay. This is the area of interest, this square part. And in this area of interest, there are two polygons and they are intersecting each other. Okay. So does this diagram require subdivision? So the answer is yes, it requires subdivision. Okay. Now, as more than one polygons are intersecting, area is subdivided. So you got a condition when we require the subdivision if there are more than one polygons and that are intersecting each other, then definitely we require subdivision. Suppose if here is one rectangle at top left corner and at bottom right corner we have one square. Okay, so in that case, will the subdivision require? No, because both the items are contained into the area of interest, but they are disjoint. Okay, so in that case, directly we can display those polygons. But as here the polygons are intersecting each other, we need to subdivide the area. Okay, so we will now see how the subdivision is performed. Now, in this diagram, we have subdivided this particular area, the same diagram we are considering here as the previous one. But right now, consider only two subdivisions here. That is only consider this A1, A2 vertical line and B1, B2 horizontal line. Okay, so consider that initially we have performed the first iteration, that is first subdivision. So I have divided this area into four parts. First, then this is second, this is third, and this is fourth. Forget about this C1, C2, D1, D2, E1, E2, etc. Okay, now I have divided this screen into four parts, that is 1, 2, 3, and 4. So I will first observe the first part. Okay, in this part, single polygon is in the area. If the single polygon is in area, we can directly color it with the polygon's color. Suppose I want to color this triangle with yellow color and this rectangle with the blue color. Okay, now this is the portion of triangle only. So I will color this portion with the yellow color. Again, I'll observe the second portion. Here also only one polygon is available and this polygon is of triangle. Okay, so again I will color it with the yellow color. Now I will observe the third portion. In third portion, I can see partial part of this triangle as well as partial part of the rectangle. That means here more than one polygons are intersecting. Okay, so what I have to do here, if more than one polygons are intersecting, then I have to divide this particular area. So subdivision occurs over here. So one, this line, and this is also line. So this particular part is divided into four parts. Okay, similarly I observe fourth part. So here also some portion of the triangle and some portion of rectangle is available. So in this case also, this particular portion requires subdivision. So again, I have divided this into C1, C2, D1, D2. Okay, with these lines, I have subdivided this particular portion. Now, first two parts are colored already. Okay, now I will observe each and every part of this. So first part I will see here, this only the portion of triangle is available. I will color it with yellow. Okay. Similarly, here there is no portion, no polygon. But here again only one polygon is available, that is rectangle part. I will color it with blue color. Similarly, here also color it with blue color. Blue color. Again here it is colored with the blue color. But now if we see these two portions here are again there are more than one algorithm. So rest of the part that needs to be subdivided and so on. So we will go on subdividing this, okay, up until the polygons are filled in with the color or they are displayed. Okay. Now the question arises that up to what level we need to subdivide. Okay. So the answer to this is what? Up to the pixel size. Okay. Up to pixel size we have to divide. So therefore maximum subdivision you have is pixel. Okay. Now suppose if at pixel level also more than one polygons are available, then what we can do, as in previous algorithms we have seen, we are going to up to that particular level, and again if the polygons are overlapping, then again we have one solution, that is you can take the z depth of the polygons, and whichever is closer to you, you can fill that particular portion with the color of that polygon. Okay, so have you understood this, how the area is subdivided into different parts and then the polygons are displayed. Okay, so that's all for this session. Thank you.